Hey guys, so this morning we're going to look at, it's actually lesson 10 from the quadratics unit. So I'm jumping out of our current unit, which is additional functions, to go back to a lesson that we didn't cover when we were in the quadratics unit that was supposed to be our last lesson of the unit, lesson 10. And I cut it short because it was, it was a tough unit, especially in this current situation. So this lesson is related to what we just learned yesterday, which is translating quadratic functions. So when you translate a quadratic function, left, right, up, or down, if you have the number inside the parentheses, if you look at the number inside the parentheses, that's like this number here, h. Let me switch colors. And if you translate the parabola up and down, it's like this number here, k. So this form has a name. When you write a quadratic function as y equals some number times x minus a number squared plus a number, that form is called vertex form. So it's the same parabola that you saw in the last unit when we wrote it as standard form, ax squared plus bx plus c, but it's just reorganized. So it's the same parabola. You can see the image here. And this form is called vertex form because when you translated it h units to the right and k units up, those numbers represent the coordinates of the vertex. So for example, in example 1, I have y equals 2 times x minus 3 squared plus 6. This is vertex form. Again, it's the same parabola that you would have seen in standard form, but things have been reorganized. And what you can tell is you can tell the coordinates of the vertex. Because this is a translation 3 units to the right and 6 units up, you can tell that the vertex, the coordinates are going to be 3, 6. So basically you take this number without the minus sign, because it's like opposite world, and you take this number with its sign and put it into coordinates. So when they ask you what is the axis of symmetry for the next question, what is the axis of symmetry? Well, remember, the axis of symmetry will always be, I'm drawing a parabola, it will always be the invisible line that divides the parabola in half, and it will always be along the same x value as the vertex. So if the vertex is at x comma y, or let's say I'll use their letters, h and k, h comma k, then your axis of symmetry is going to be the equation of x equals h, whatever the first number was here, the h value was. So if I ask you for what's the axis of symmetry, you just go to this number, 3, x equals 3, or this number here, 3. But you have to state it as an equation, x equals 3. And then does the parabola open upward or downward? Well, to know that, you go to the a value. The a value is here, right? Remember, we talked about this yesterday. If it's positive, it opens up. If it's negative, it opens down. So it's positive, so it opens up. Will the parabola be wider or narrower than y equals x squared? Remember, y equals x squared is your parent function, and that's the width of it is standard. As the absolute value of a gets bigger, we went over this yesterday, your parabola becomes more narrow. It becomes a vertical stretch. And as the absolute value of a gets smaller, your parabola becomes wider. It becomes like this, and it's called a vertical shrink. So this 2 tells me that the absolute value of a is getting bigger. This is going to be narrower, or a vertical stretch. Okay, so if you want to maybe pause me for example 2, and you can try example 2, figuring out the coordinates of the vertex. That is a negative in front of the 1/3. So the coordinates of the vertex here, for example 2, would be -4, because it went left 4, and down 2, so -2. Those would be the coordinates of the vertex. The axis of symmetry is going to be whatever that x value was in an equation, x equals -4. Does the parabola open up or down? Well, the 1/3, the a value is negative, so it opens down. And will the parabola be wider or narrower than y equals x squared? It will be wider because the fraction is smaller than 1. Okay, and it'll be a vertical shrink. So you'll have a couple of problems like this on your homework. Next thing you need to know is how to convert from one form to another. So converting from vertex form to standard form. So converting from vertex form to standard form is, in example 3, is the easiest. This is the one where you're given vertex form, and all you have to do is multiply using FOIL and simplify. And that will convert you to standard form. So if you see x minus 3 squared, that means x minus 3 times x minus 3, and then add the 6, and then you'll be in standard form. So I'm going to get x squared minus 3x minus another 3x plus 9 plus the 6. And when I combine those, x squared minus 6x plus 15, now I am in standard form. Okay, those are easy. Example 4, you can pause me and try that one. I'm going to FOIL first, then I'll distribute the 2, and then I'll subtract the 3, and I'll be in standard form. So I have 2 times x squared plus 5x plus another 5x plus 10 minus 3. I have 2x squared plus 20x plus 20. Oh, hold on, mistake, sorry. 5 times 5 is not 10, 5 times 5 is 25. Let me erase that, I'm trying to erase. Okay, I don't know why this is not erasing. Okay, so that was 25. So this is going to be 50. Minus the 3 equals y. So standard form is going to be y equals 2x squared plus 20x plus 47. Okay? Now, the harder thing to do is to convert from vertex form from standard form to vertex form, and to do it by completing the square. This is going to be something that is pretty much you're completing the square like you did in our last unit, but you're doing it in a different way a little bit because you're not solving the equation. Okay.